Our next lesson in Chapter 9 is Geometry's Most Elegant Theorem, 9.4, which you guys will more commonly know as the Pythagorean Theorem. So hopefully you remember this from last year, the Pythagorean Theorem and its converse. This stuff should look familiar. We are going to just, use that Pythagorean Theorem, but we're going to use it so much. From here on out, Pythagorean Theorem almost every single day in every single lesson. So we're going to just review it today, and then we're going to show you some new ways that you might see it in your problems. All right, so here we go, Pythagorean Theorem. So if you remember back from last year, the Pythagorean Theorem has to have a right triangle, right? So you have to have a right triangle. So if we wanted to write the Pythagorean Theorem in if-then form, it would say if a triangle is a right triangle, then... and then here's the good stuff, right? A squared plus B squared equals C squared. That is the Pythagorean theorem. A squared plus B squared equals C squared. So A, B, and C, we have to remember what those are all about, right? So if I have a right triangle, remember that the side across from the right angle is the longest side, which is the hypotenuse, right? The hypotenuse is always across from the right angle, and this is also the longest side. Then on either side of that right angle, I have the legs, right? One leg, another leg. It doesn't matter which one is which. Those two sides are just called the legs. Now, if I wanted to get A, B, and C here from our formula, C is always the hypotenuse. So C is the longest side, the hypotenuse, every time. It's got to be the side across from the right angle. A and B are the two legs, and it doesn't matter which one you call A or which one you call B, right? It doesn't matter. You're adding them, you're squaring them both, so whichever one you want to put first it is. So leg squared plus leg squared equals hypotenuse squared. That is what the Pythagorean theorem is all about. But the biggest thing to use the Pythagorean theorem is that you must have a right triangle. You cannot use the Pythagorean theorem without having a right triangle. So sometimes we even start with the converse a little bit, right? So I'm sure that if I gave you some numbers, said solve for x, you'd be able to plug in and figure it out, right? So sometimes the converse gets a little bit trickier. So the converse is, if I flip that around, the converse would say, if A squared plus B squared equals C squared, then the triangle is a right triangle. So the leg squared plus the leg squared equals the hypotenuse squared only in right triangles. So if you know that A squared plus B squared equals C squared, then the triangle has to be a right triangle. If A squared plus B squared does not equal C squared, then the triangle is not a right triangle, right? So using the converse here, we can just go ahead and see, are these right triangles or not? Well, remember, C is always the longest side, right? So even though we don't know where the right angle is, we can still look at the numbers and know which side would have to be C. In the first triangle, C would have to equal 8, right? So A and B would be 5 and 7 in whatever order you want. So we could say 5 squared plus 7 squared. We're wondering if that equals 8 squared. 5 squared is 25. 7 squared is 49. 8 squared is 64. 25 plus 49, that gives me 74. Ooh, 74 does not equal 64. So this is not a right triangle. Kind of get the idea? Why don't you guys go through and do the other two, see if you get the same thing that I do. All right, let's see. On this one, 5 would be C, so I'll have 2 squared plus 4 squared, supposed to equal 5 squared. 2 squared is 4, 4 squared is 16, 5 squared is 25, 4 plus 16 is 20. 20 does not equal 25. That's not a right triangle either. All right, last one. Ooh, tricky. C would be 10 on this one. So I have 6 squared plus 8 squared equals 10 squared. 36 plus 64 equals 100. 36 plus 64, 100 equals 100. Yes, this one is a right triangle, right? Okay, so that's how you would use the converse, right? Is it a right triangle or not? Now, that's what we did last year. We did that before. This year, though, I think you could even take it a step farther, right? Knowing what we know about the sides and the angles with our triangles, right? So in this case, in our last one, our a squared plus b squared equaled c squared. They exactly equal, so that would be a right triangle. We know that, right? Which means our right angle would be here. It doesn't look like it, but it would be here across from the longest side, right? So let's think about what these other two would mean. Okay, let's go back to this first one, this guy right here. So when I square these, I get the length of my two legs is longer than my hypotenuse, right? Now this triangle is not necessarily drawn to scale, right? But that means that when I square it, my two legs are longer and my hypotenuse is shorter. That's kind of the idea here. Right now, normally in class, I'll get out my, what I call arm triangles, and I put my arms together and say, okay, if my legs are really long and my hypotenuse is short, so here's my arms coming together, right? That means if this side is shorter, what kind of a triangle do I have? Or if I look at the next one and this other one, the legs are shorter than the hypotenuse squared, right? So the hypotenuse squared is really long and the legs are shorter, right? So what type of triangle would that be? So if my legs are long compared to my hypotenuse, the a squared plus b squared is bigger than c squared. If a squared plus b squared is bigger than c squared, that means I have an acute triangle. And if I have like our middle one here, where the hypotenuse is really long compared to the two legs, so a squared plus b squared is shorter than c squared, right? C squared is the longer side. That means that I have an obtuse triangle. So that's kind of taking it even a step farther than that, right? Now, that's not too big of a deal that you remember, but it's good to have in your notes, and it might pop up here and there, maybe on an extra credit once in a while. But, the biggest idea is that a squared plus b squared has to equal c squared for it to be a right triangle. If a squared plus b squared is bigger than c squared, it's an acute triangle. If a squared plus b squared is smaller than c squared, then it's an obtuse triangle. So that's how we use the converse. All right, so enough with the converse, right? Let's actually use that Pythagorean theorem, but I know that if I just give you some triangles with a missing side, you can do it, and I probably will. But here in our notes, let's look and see some different ways that we could see this. This says, find the perimeter of a rhombus if the diagonals are 6 meters and 10 meters. Ooh, a rhombus. So you got to dig back in the archives and remember what a rhombus is from chapter 5. So if I recall, I know the defining factor of a rhombus is that all sides are congruent, right? Okay, so if I find the length of one side, I can multiply it by 4 to find the perimeter. Now this also says something about the diagonals. Do I remember, what do I know about the diagonals of a rhombus? The diagonals of a rhombus are perpendicular bisectors of each other. So both diagonals are bisected and they are perpendicular. That means that we are going to have some right triangles, right? So let's see. If one diagonal is 6 meters, that's the shorter one. So that means when it's bisected, they would both be 3, right? 3 and 3, whole thing is 6. The second diagonal, the longer one, was 10 meters. So if it's bisected, each part will be 5. 5 and 5 would make it 10. Now, are you seeing my right triangle right here? So I can use my Pythagorean theorem because I have a right triangle. One leg is 3, one leg is 5. The side across from the right angle is the side that I don't know. Okay, so the side across from the right angle, that's x, right? So that's my c. So when I set up my formula here, it will be 3 squared plus 5 squared equals x squared. And that's probably how you're used to seeing the Pythagorean theorem in a situation like that, right? But we had to set it up a little bit differently here in geometry. All right, well, let's see. 3 squared is 9. 5 squared is 25 equals x squared. 9 plus 25 would give me 34. All right, x squared equals 34. So I'm going to square root both sides because I need to figure out what x is. Ooh, 34. 34 is 17 times 2. 17 is prime. 2 is prime. No perfect squares hidden in there. So I'm just going to leave it as radical 34, right? Now, technically, we could write the plus or minus in our work and know that the negative doesn't make sense, right? So it's got to be positive 30, radical 34. So x equals positive radical 34. I wanted to find the perimeter of this rhombus, which means every single side is radical 34. And how many sides are there? 4, right? So the perimeter would equal 4 radical 34, right? That's how we would multiply that. 4 radical 34s. They're not both on the inside, so I can't multiply. So it's 4 radical 34 is my perimeter. Ooh, I do have a label here. 4 radical 34 meters. All right, so that's more how you're going to see in geometry that Pythagorean theorem showing up. It's going to be embedded into different shapes. This shape we actually had to draw ourselves, but sometimes you won't. How about the next one here? Oh, Nadia skipped 3 meters north, 2 meters east, 4 meters north, 13 meters east, and 1 meter north. How far is Nadia from where she started? Sounds like I got to draw a picture. So here we go. Here's her start. She's going to go 3 meters north. 3. Then she's going to go 2 meters east. Whoa. 2 meters east. This way is east, so there's 2. 4 meters north again. There's 4. 13 meters east. And then finally, 1 more meter north. And this is where she finished. Oops. So it says, how far is she from where she started? So what I'm trying to find is the distance in a straight line from start to finish. That's x. Now, a lot of people, when they see this, they really want to break it into little triangles. They say, oh, I want to find this, and then I want to find this, and then I want to find this. The thing is, if you notice how that happened, those don't add up to that pink line, right? They don't exactly touch where I think that they should. So that method doesn't work. Instead, what I need to do is I need to think, okay, what would be the sides if I created this really big right triangle? Sorry, I'm trying to draw it straight for you. How could I do this really big right triangle? Well, okay, well, all my left to right ones, if I start here, well, that would be 2 plus 13. Oh, 2 plus 13. 2 plus 13, that gives me 15 down here, right? And what would be all of my vertical ones here? 3, 4, oops, and 1 more. 3 plus 4 plus 1, that would be 8. So this side would be 8. So I would have 8 squared plus 15 squared equals x squared, right? Because x is the side across from my right angle. Let's see, 8 squared is 64, 15 squared is 225. This equals x squared. 64 plus 225, that gives me 289. Square root both sides. Oops, square root. Square root of 289 is 17. Now again, I could put plus or minus 17, but this is a distance, right? So it can't be negative. So it's positive 17, and we are talking about 17 meters. So she is 17 meters from where she started. So there again, even if we draw our triangles, we can still figure it out. Just make sure that you have a right triangle and that everything connects, right? All right, last one here. Ooh, this looks a little bit familiar, doesn't it? This looks like altitude on hypotenuse. I see my right angle up here at the top for my snow. I see a right angle down here at the bottom. Let's look and see what we've got here, though. Ooh, okay, down the mountain to the left is 12. Down the mountain to the middle is x. That's what I'm trying to find. Gosh, sorry, guys. I don't know why it's jumping around so much today. Down the mountain to the right is 16, but I have nothing on the bottom. Oh, man. Pythagorean theorem is going to be tough. I mean, altitude on hypotenuse is going to be tough. Maybe I could use Pythagorean theorem, though. So let's see. I have my big right triangle, don't I? Oh, if I have my big right triangle, this whole side would be y, right? And that would be the side across from the right angle. So I can use Pythagorean theorem maybe to start us off to figure something out here for that bottom part, so I could use some altitude on hypotenuse. So leg 1, 12 squared plus 16 squared equals y squared, right? From that big whole right triangle. So that means I have 144 plus 256 equals y squared. 144 plus 256, 400 equals y squared. Square root both sides. Y equals, square root of 400 is 20. Technically, we could write plus or minus 20, right? But this is a side length, so negative doesn't make sense. So positive 20. So this whole thing equals 20. Now, if I wanted to use my altitude on hypotenuse to solve for x, right? I would come down this way, I would go right, and I would go left. I don't know left or right, but I know the whole thing is 20. So I'm not ready to do that just yet. But if I come down this way, right, I would have, so altitude on hypotenuse, if I came down 12, that would be 12 squared equals, where could I walk? AD, I don't know that yet. But I do know the whole thing is 20, so maybe I give this another letter. Maybe I give this a W. So 12 squared would be W times 20, right? Or 20W. All right. 12 squared is 144, which equals 20W. Divide both sides by 20. Ooh, a little bit messy, but okay. W equals 144 over 20. I know I can reduce that. Let's see, I could definitely divide by 2. Ooh, maybe 4? Could I divide by 4? Yeah, okay. W equals 36 over 5. Or I know you just typed that into your calculator and you got 7.2. Fine. Okay, 7.2 it is. 36 over 5 I would like, but I understand probably 7.2. All right, well, let's see. If that left part is 7.2 and the whole thing is 20, then I could say this part is 20 minus 7.2. 20 minus 7.2, huh? Be 12.8. Now I could use altitude on hypotenuse again, but ooh, both of those are decimals, yuck. Or do you see that maybe I didn't even have to find that 12.8 because right here is another right triangle. My right angle goes this way as well, right? So I could use my x, my 7.2, and my 12. Let's do that. That seems to be easier than doing multiplying with all my decimals. All right, so here I go, finding my right angle, Here's my right angle, side across is 12, so 12 is going to be C, right? So last step here is going to be the Pythagorean theorem again, but again, you could have used altitude on hypotenuse if you wanted to. So I have x squared plus 7.2 squared equals 12 squared. X squared plus, I know you're typing that into your calculator right now, 51.84 equals 144. Minus 51.84 on both sides. I get x squared equals, gosh, this is why I really do not like decimals with radicals. There is no way I could do this without a calculator, but we've got it. We're there. We're moving. Square root both sides. Type it into your calculator. Square root of 92.16. X equals 9.6. Technically, again, plus or minus 9.6, but it is a side length. So 9.6 it is. All right, so we gotta be real careful, right? When you get those right triangles, is it altitude on hypotenuse or is it Pythagorean theorem? And I wanted to show you a problem where both of them were involved in the same problem. Are you gonna have something that's this complicated with decimals and all of that stuff? Probably not. But could you encounter a situation where you have to use both altitude on hypotenuse and Pythagorean theorem in the same problem? Definitely. And can you deal with decimals? Sure, you got a calculator, right? You can do it.